Hello, back with another trigonometry video. We're going to be sticking with our non-right triangles, and I've split it back up into two right triangles, just like I did in the sine law derivation video. Taking a look at this, we had a problem. Maybe you didn't realize it at first, but the problem with sine law is that you always need to know, if you know angle B, you need to know side B in order to find out information about another matching pair. And so if we want to fix that problem, then we're going to have to be a little bit more general when we're dealing with deriving another law, which you can tell by the title of the video will be cosine law. And so what if we knew side A and side C, and we wanted to find angle B? Well, now we don't have a pair. We don't know anything about angle C. We don't know anything about angle A. And so now we wouldn't be able to use sine law. And so in this case, what we have to do is we still need to split it up, but we have to think about how this side now factors into things. And so I'm going to just put a letter here. That x is the distance between there and there. Okay, which makes this length here the whole distance a minus that distance x. So this is a minus x. So we'll do what we did before, and we're going to split this up into a red triangle here and a green triangle over there. Okay, so let's go into the red triangle world first. So the red triangle here. And so what we'll do is we'll write out some information about this red triangle. One thing we know is we know something about Pythagorean theorem. So we know b squared is equal to x squared plus h squared. Okay, let's just leave it there. Okay, let's go over to the green triangle, because that one has the angle that we want to talk about as well. So our green triangle, let's write out the Pythagorean theorem for that as well. We've got c squared is equal to a minus x all squared, okay, plus h squared. Okay, and I'm going to do something right away. I don't want to live in the h world. I don't want to know anything about the height, because then we have to split the triangle up, and likewise we don't want to really have x's involved either. Okay, so let's just rearrange this guy here. We use blue for our rearrangement, and we'll write out that h squared is equal to b squared minus x squared. All I did there was I subtracted x squared from both sides. And I just wrote it in the opposite order because I just find it easier. So now I'm going to take this and I'm going to write it in for that h squared. Okay, so what do we get when we do that? We've got c squared is equal to a minus x all squared plus b squared minus x squared. Now, we still have this problem that you've got x's in here, but maybe that'll work itself out. I'm just going to square this. This is a perfect square, so I know I've got h squared minus 2ax plus x squared plus b squared minus x squared. Okay, so now when we take a look at this, we've got a cancellation of x squared, because x squared minus x squared is nothing. And so we simplify this, and we get a squared. I'm going to write it a squared plus b squared, because that's in a form that we're sort of familiar with, plus 2ax. Okay, so now we just have an x. Man, if we could just get rid of that x somehow, then we'd be set. And so, so what am I going to do here to get rid of that x? Well, I'm going to go over to this angle here, c. I'm going to think of the cosine of that angle, because it has an x in it and has a b in it, but it doesn't have an h in it. So we don't want to start adding h's in by doing sine or anything. So when we're dealing in that red triangle again, what do we got? This is back in the red triangle. We've got the cosine of c is equal to the adjacent divided by the hypotenuse. And in this case, the adjacent is x, and the hypotenuse is b. Okay, so x then is equal to b cosine C. And hopefully you realize why that solves our problem. Now we don't have any x's. Now we again only have outside measures, the angles or the sides. Okay? So let's take this x, we're going to write it in there. So what we end up with is c squared is equal to a squared plus b squared minus 2ab cosine c. And now I know that I originally talked about angle B, but now what we've done is we've derived an equation that deals with angle C. Now I could have done the opposite, right? I could have labeled this side as x and this side as a minus x. If I had done that, well, then I would have been dealing with the B measurements. Okay? And likewise, I could have, again, like I talked about in the sine video, I could have split this up into a triangle that actually goes this way as well. If I did that, well, now I'd be dealing with angle A. And so there's actually three formulas that we get from this. So let's write them out. This is called cosine law. We get a squared is equal to b squared plus c squared minus 2bc. You can put this in a bracket, cosine A. Just put that in a bracket because I don't want you to get confused that there's c here and then cosine starts with the letter c. Then we got b squared equals a squared plus c squared minus 2ac. And again, I'll do the same thing, cosine b. Put that in brackets. C squared is equal to a squared plus b squared minus 2ab cosine c. There you go. There's your three forms here, right? Put that in brackets just to keep it the same. Now, some people will rearrange this equation so that you can solve for cosine C, B, and A, and I think that's just a little bit of extra complexity. You can always just rearrange. It's not really that hard. Okay, so I'll show you how to do that once we get to some examples with cosine law, which I'll do in another video.